Next question, block of mass 14 kg moves along a plane, and this is block of mass 14 kg makes an angle of 3 degree with the horizontal. Block A is connected to another block B of same mass by a taut massless string that runs along a frictionless mass pulley. Block B moves downward with constant velocity. That means the acceleration here is 0. And what is the magnitude of the frictional force? So this block moves upward, uh, and the force of friction plus the vertical component mg sine theta is in the downward direction. This is the horizontal component. This is the horizontal component, sorry, mg cos theta. Okay, this is the weight that is acting vertically downwards. This is 30 degree, and now the block is moving up. So this is the tension T in the string. This is the tension P. The weight is acting vertically downward. This is M2G. This is mass of the first block M1. And now we have to calculate the force of the friction. So the tension is balanced. That is M1G sine theta plus force of friction is balanced by the tension T in the string. So we have to find the force of the friction. So the force of the friction is equal to tension minus M1G sine theta. Now the tension P in the string is, in this case, is balanced by the weight of the second block. P is equal to M2G. So let's put in the value here. So the force of the friction is equal to M2G minus M1G into sine theta. Let's put in their respective values. So the mass is same, 14 kg into 9.8. M1 is also 14. So this is 14 into 9.8 into sine 30 is half. So this is 4.9. So now the force of friction is equal to 14 into 9.8 minus this is 14 into 4.9. So the force of friction is equal to 14. This is 9.8 minus 4.9, which is equal to 14 into 4.9, which gives us the force of the friction is now equal to 68.6 Newton. So that is 68.6 Newton. Now the next one to find out is the coefficient of friction. So the force of friction is here, and we know the coefficient of friction is the maximum force of the friction divided by the normal reaction. The force of the friction is 68.6. R is balanced by the horizontal component mg cos theta. So let's put in the respective values. 68.6. M is 14 of the first block. G is 9.8. Cos 30 is root 3 by 2. So this is 4.9. And so this is 68.6 divided by 14 into 4.9 into 1.732. If we calculate this, it will give us the value 0.58. So the coefficient of friction is 0.58. Right. Okay, with this we are done with finding the magnitude of the frictional force and the coefficient of kinetic friction. Do like, share, and subscribe. Thank you for watching.